So bridge section is part of the statewide project delivery branch. We've all heard about this here this morning under David Kim. Actually, David Kim's name is not up there. Instead, we are dropping down one more level here. Steve Cooley, Technical Services Manager. So bridge section, Bruce Johnson is a state bridge engineer, reports to Steve Cooley. Bruce Johnson is basically responsible for all of the technical oversight to bridges in the state of Oregon, state and local, and even in some cases private bridges. There is 4 units in the bridge section. We have the Bridge Operations and Standards unit. We have a Bridge Preservation unit. We have a Bridge Program unit. And then my unit, Bridge Design unit. What's kind of particular to note on this slide, though, is we have the 5 region leads, region bridge lead engineers, of which Bob is one of those. Bob is located down in Roseburg, but each of these, there's one in each region tech center. So you heard a little bit here earlier about decentralization in 2004. Bridge was part of that. They went out to the regions at that time. And then there was a re-centralization that occurred 2014, in which decided, well, we need to bring bridge back together, bridge design back together for, as mentioned, like technical competency purposes here. We had some regions that just had, 2 people in it, and they weren't really coordinating with the other regions, and that was becoming kind of a problem for the agency. So by bringing this all back together, we now operate as one unit statewide. So I'm the manager of that. I actually sit in Salem, and all my reports are around the state. I'm going to talk a little bit about the bridge design unit first, and then how that relates to all the other units in the section there. So the next 5 slides, I've been asked to focus on project delivery and bridge design. So in particular, what does bridge design do? Tools used in bridge design, design deviations, the design quality process that we use, and then what deliverables are produced by bridge design. So, what do? Well, bridge design actually does more than bridges. And we work in many different programs, not just the bridge program. So we'll do work in modernization, fish, culvert, preservation, safety. There was a slide this morning that David showed about all the House bill money and the different programs. So we actually work in all of those. And we also work in maintenance, the maintenance program, quite a little bit. So we do, besides PS&E documents, which you've heard a little bit about, we do new bridges, replacement bridges, rehabilitation and retrofit of existing bridges. And then I mentioned maintenance. We do maintenance design and emergency support, to maintenance. We do culverts and pipes greater than 6 feet. The 20-foot number noted there is anything over 20 foot actually has to be inspected as a requirement by federal highway. We do retaining walls of various types, including reinforced concrete, steel sheet pile, and soldier pile walls. We do sound walls, the structural analysis again of the sound walls. Traffic structures, you heard a little bit this morning here about trusses and monotube sign supports. We do the structural analysis for those, and also including signal poles and illumination poles. And then once in a while we have subsurface structures dealing with vaults and inlets and outlets that are underground. So we do a wide variety of different structures. So tools used in bridge design, there's kind of 3 categories here. The bridge structures design-centric, as I've dubbed them here, and then we have bridge data, and we have project delivery. So so bridge design, I don't know, you're either fascinated by it, or it's like the last thing you want to do. We do a lot of work with design codes. So, you got a notebook here in front of you. Well, we got tons of these notebooks in front of us with all sorts of AASHTO codes. We have a design manual like many of the other disciplines do, and it's eloquently called the Bridge Design Manual, or BDM. So here's another one of these acronyms. I don't think we've heard BDM yet today, so new acronym for the afternoon. The BDM contains our design policies and procedures, standards, and guidance. We also use a lot of other manuals, so by the other folks. We've heard of some of them today. We have the Highway Design Manual with the design criteria that was talked about earlier, 1R, 4R. We have a load rating manual that we use, Historic Bridges Field Guide, the Geotech Design Manual, ADA Guidelines and Traffic Structures Manual, Retaining Wall Manual. The list goes on. What, 129 this morning? There's a lot of manuals out there. Bridge section does not use technical bulletins and advisories. We honor their use by the others, but bridge section elects to update their BDM every 6 months. So rather than putting these advisories out and bulletins out, we do the update and the information gets put into the manual. Other tools that we have, Transportation Research Board and other such reports, and these are national publications that provide current research and knowledge in arenas of bridge design. They cover many different subjects applicable to new and existing bridges. Structural analysis applications or programs. So this is the other part. You either like it or you don't. Our world is a math-based world. We run a lot of structural analysis programs using computers and high-end structural analysis programs. And then we also have load rating applications and reports. And these are specialized bridge analysis applications that assess the ability of a bridge to carry vehicular live load based on their weight and spacing of axles. So if you're driving down the road and you see a sign, it says, well, hopefully it doesn't say bridge closed, but it might say weight restricted. That's what becomes of doing a load rating and finding that the bridge can't quite carry the big loads that we're seeing, these days, because it was designed maybe 50 years ago or something for a little less load. We do things to try to keep all those bridges, carrying the loads that our legislative body says that they need to carry, but they get old, and we don't want failures or disasters to happen, so we sign them for the weight that can cross them. Okay, so materials that are bridge data centric here. We have the bridge management system and bridge inspection reports. And this is a bridge asset inventory system recognized by Federal Highway, in which, among other things, bridge inspection data is stored, bridge conditions are queried and analyzed, and then dockets of work are generated from that eventually become that 100% list for the STIP. Let's see, materials and programs that are project delivery in nature. We've heard a lot already, business cases, project charters, project management plans. And then bridge design, when we re-centralized, we created what was called the Bridge Design Work Order. I'm going to let Bob talk more about that here in just a little bit. So these are it's a progression of documents that, among other things, they refine and describe project scope to help avoid scope creep, or what I like to really call scope explosion. MS Project was mentioned earlier. We use that to track our schedule so we stay on time with our delivery. So those are our tools. Can't read this. It's just basically a picture of a spreadsheet to say, yes, we have a very rigorous deviation and exception process that we follow in bridge design. Reality is every discipline really needs some type of deviation or variance process to address when we're not meeting standards. So while each discipline may be responsible for certain standards and exceptions, designers need to collaboratively work together to identify and prepare these documents, which are sent to people that have the positional authority to approve or reject. So I think you heard a little bit this morning, Steve Cooley talking about a couple of the positions that are by law required, chief engineer, state bridge engineer. Those people have positional authority for certain things. And in this case, the state bridge engineer has that positional authority to approve or reject bridge design deviations. So quality program, yes, we have one of those too. So you've already heard kind of two types of quality programs here through the day. You heard about the design phase milestone reviews. And then you heard Melissa Sikowski talk about the PS&E package QA review by OPL. So bridge design has a little different one. Well, first I should say that design quality programs should be based on value of the feature and then the risk and consequences of that, of failure of that feature. So bridges are typically high value, and the consequences of failure are pretty great. There's a lot of money. It could be pretty catastrophic. So we don't want failures in our bridges. Because of that, Federal Highway has pretty stringent requirements of bridge design in their quality program. So we perform internal QC/QA of our work and any deliverable submitted to the project leader before the milestone review. So the discipline, bridge design, has actually already looked at that. We have a second designer that actually looks at the first designer's work. So when it gets turned in, it's really just a review of, you might say, the PDT peers and whether or not everything's working together. Plan, specs, and estimate, they get the same quality review before they're sent in. And then other deliverables such as our type size and location report, TSNL, new acronym. So, they also receive a review by the quality or bridge design reviewer. I think there was a mention, I just want to say it was in the last presentation here for right-of-way, but there was a mention of the region QC plans. So regions have a quality control plan that the Region Tech Center manager is supposed to be using, to review all those deliverables, those packages before they move on. But that's another aspect of quality review that I ask the leads to do before stuff gets sent in, is we actually look at it in relationship to that region's quality plan. So a lot of quality associated with the bridge stuff here. Let's see, deliverables. So we have the typical, we follow the typical STIP project schedule. We have the typical bridge plans, specifications, cost estimate, deliverables, but we also have a lot of other deliverables that don't get sent into the project leader. Sounds kind of weird. They actually get sent either to me or they get sent to the bridge section. Best example of that is, I mentioned that we are a mathematical-based unit here, so we produce structural calculation books for basically every design, every bridge, every pole, every whatever it is we're designing. And those don't get turned into the project leader. They actually go to the state bridge engineer. And that's actually, I would probably consider that to be our mission-critical deliverable. Now, some people might say, how can that be? PS&E, you got to get the PS&E out for construction. But quite frankly, if we don't run the calculations, if we don't feel good about what we're putting on those plans and in the specs and in that estimate, I don't want to set a plan, specs, and estimate going out without that calculation book being done and being checked. So besides, the typical plan, specs, and estimate at preliminary, advanced, final milestones, everything we've kind of heard about here, some of the others that we have for in-house design, I got some different times noted here. Near the project initiation, we heard about this morning, there's advanced investigations that could be getting done. It's actually something new. But load ratings, deck testing. We have a lot of deck work that we're doing. So we test for chloride contents, compressive strengths of concrete. And then analysis and assessment of seismic resiliency of our existing bridges. So those are all things we're finding that if we had that up front, we have a better scope and a better success in delivering the project without changes near the end. At project kickoff, we do a design criteria and standards assessment, and we get our deviations going at that point. Sounds kind of weird, we just kicked off. But there's really a lot that we know at that point in time that we can get started. About midway between the kickoff and DAP, we do a bridge proof of concept. And I think we heard the acronym PDII earlier, Project Delivery Improvement Initiative. I think the proof of concept is actually something that's going to be showing up, I think, in just a typical schedule for the whole team to be recognizing. But we also update our design criteria and standards assessment at that point. At the DAP milestone, besides the DAP report, we also have the type, size, and location report that I mentioned earlier. And we do an update again to those design criteria, standards assessment, deviations. And then I know it was mentioned earlier that, I think by Sean, that we have like unique specifications that get started by preliminary. We actually start ours earlier. We prefer to have them going by DAP. We've just had cases in the past where if we didn't do that, we were blowing the schedule at the end of the project. At PS&E, everything gets signed up. Plan sheets get signed up, specs get signed up. The calculation book gets signed. We turned in all of our quality documentation. Well, actually now it goes into ProjectWise. That's really nice. Load ratings get updated, or if it's a new bridge, we create a new load rating. Our structural analysis programs, we get those into ProjectWise, and then all the CAD files get archived at that time too. Outsourced projects are a little bit different. I think it was mentioned earlier. Statement of work reviews, helping project leaders create statement of work, helping them with the cost estimating, and sometimes helping in negotiations. Those are all what I consider deliverables for us. Local agency projects, we're not so much involved in those anymore, but every once in a while we do what's called stewardship review, documentation and comments if the regions ask us to get involved. And one more here on the outsourced projects, we do what's called a review and acceptance of any A&E deliverables that get sent in. So those are long list of deliverables. Let's see. So now a little bit, moving back over to some of the other units here in the section. And then other disciplines. So first are the other units. So the Bridge Preservation Design unit, they do engineering analysis and design very similar to my unit, but it's for special applications associated with preservation of bridges. So painting of steel bridges, they typically do those. My unit, we'll dabble in it once in a while when they let us do that. Mechanical and electrical aspects of movable bridges, and then cathodic protection of concrete bridges in coastal environments. So they tend to get into some of the more specialized work, design work. That unit is actually located in the TLC building, and we interact with them quite a little bit. Bridge inspection, they maintain, so bridge inspection operations, they provide inspection services mandated by Federal Highway, which is really independent of the project delivery process. They inspect culverts with a clear span greater than 20 feet, mentioned that earlier, and then inspect bridges, and they also inspect tunnels. However, where they do fit into the project delivery is they are called upon. They basically provide a consultation service to project design teams, or really the bridge designers on the project design team, in helping to set scope. You know, a lot of the condition, you might say, of the bridge, what we need to do to it to repair, to fix it, is noted in those those bridge inspection reports. And they can actually do that kind of throughout. It's mostly at project scoping, but project initiation, kickoff, hopefully not past DAP anymore. We might be calling upon them to identify things. Bridge standards, they maintain the engineering standards and tools that we just talked about here back on a couple slides back. They also provide technical expertise and training to the bridge designers that are actually in that production mode of producing those contract documents. They too provide a consultation service to in respect to design deviations. They review and approve them. Well, they review them and they make recommendations to the state bridge engineer, again, for the approval or rejection of those deviations. And then lastly, they can get involved in doing quality audits for bridge design work to make sure that our quality processes that we do follow are being done according to the BDM. I'm sorry, I should be flipping through these, so here we go. Yeah, look at that. Okay, bridge program. There is, so, and I made this observation here in David Kim's presentation, so I forget how far down in there, but one of the things that was on his list of things that were going to be done here in the next 6 months, at the very bottom of that list was bridge program. So what I tell you right now, I'm not sure if it's going to be applicable after maybe 6 months or so. But anyway, here's the way it's been. So bridge program is responsible for maintaining the bridge management system. It's a program that maintains asset inventory and conditions of the bridges, and then delivering various reports to agency and to Federal Highway. So they basically plan and program the work that's developed and delivered through the bridge program. They're typically contacted by region project leaders, area managers, if there is a change or if there's consideration of a change in scope, schedule, and budget, because it's the program that holds the dollars. Myself in design, I have people, I have resources that could be put on projects, but I have no money. So I'm one of those people that's always asking for an EA. Also inside the bridge program is the load rating unit, or load rating group. And we talked a little bit already about load rating of bridges, posting of bridges. These are the folks that, that's all they do, is day after day is load rating of bridges. And the state has 2,700 bridges on the state system. I think there's about 6,000 or so in the state, and they're pretty much responsible for ensuring that there's a load rating on all those and it's up to date and available. Another thing that they do is when you get these super loads that are coming through these heavy trucks, here a little while back when they were building all the windmills up in the gorge, those haulers of those components they got to call in. They got to say, how can I get this heavy load from point A to point B, and those folks, they map out a route for them to follow. All right, so the last one here for coordination. So project team can have a lot of people on it, and we need something usually from each one of these, and we generally have to give something to each one of these folks. When I introduced myself this morning, I said I've been around for about 30 years. I started with ODOT in 1985. I left during the decentralization and went to the private sector for 10 years and then came back, so I've been back for 5 years. I left as a bridge design manager. I'm back as a bridge design manager. It's kind of weird. But one of the things I learned while out in the private sector, I was actually more of a project manager out in the project or in the private sector. Doing the PDO2, getting stuff through OPL, making sure the project team is talking to each other. And one of the big things I learned is you, most often than not, you don't know everybody around the table. I mean, you know them, you've been introduced, but you really don't know what they do. And without actually learning or doing their job, I'd say you got to learn enough to know what they need from you. Because if you can give all of these folks what they need to do their job, they're going to be able to do it faster, sooner. They get you what you need, and you get the job done. So get to know the folks. I just listen up. I'm not going to go through all of them here. Maybe just a couple here on the end. Survey. Survey just needs to know what we need surveyed, especially on the old bridges. We just had one here the other day. We realized we needed a deck overhang dimension. How far is the deck hanging out from that exterior girder? We'd missed that. We get the information from them. Geotech, we give them a footprint. We let them know where we think the abutments and piers of the bridge is going to be. We give them estimated loading, and they give us some design parameters that we need to run our programs. Railroad, just heard about those folks. We give them a design, final plans or near final plans, and we get the permits to be able to get on or over that railroad. There is another group of people here that's not on they're not officially on the project team. And I call them the others who care, and we've kind of heard about them here a little bit today. The technical specification experts. They're not on your team, but you got to get your information through those folks. There is people in the construction section structural services group that at least we in bridge design have to satisfy when we're dealing with decks and other things. And then of course the OPL quality engineers is folks that you just have to make sure they're getting what they need. There should be no verbal approvals, at least in bridge design. I'm saying no verbal approvals. Everything should be in writing, even if it's just email. There are other bridge section units, other disciplines that will accept verbal approvals, but check with your managers and supervisors to see what they want you to do. And then, of course, every project has a lesson learned, and with that, I'm going to turn this over to Bob, and he's going to give that key takeaway presentation here for us, bridge design.
All right, is this thing working? All right. Last guy of the day. You guys been here 8 hours. Everybody looks energetic. Not really, looking kind of sleepy. I'll be on this side of the room. This side of the room has been ignored today, so if I can tell anyways, they need the most woken up. It's my job here to tell you, as the guy who uses this stuff, all the stuff Scott was talking about, the manuals, all the endless calculation books and things that we do, and the requirements that we have. Lessons I've learned over my career, time here at ODOT. It's been a while, it seems like. The bridge design work order that Scott talked about earlier. Best way for me to explain that, it's just documents what's needed. We have somebody come to us, a project leader, a district manager, they need something from bridge design. They come to you and say, we need this. And it's our job to find out what they really need. What does the requester really want? A lot of times they don't really know what they want, which is the surprising thing for them. You start asking them those questions and make them think of what they really want. We want to get that information from them and document it. It's our goal, when we do this work order, to be able to give it to one of the designers, and they have everything they need to do that work. They know what's needed of them. They need to know when it's going to be done, who's asking for that work. We have a schedule. We know what type of quality control we're going to perform on this job because we have different levels of quality control that we do. We document all that. The way I like to think about it is you can go to a restaurant. You're a customer, you sit down, and you're hungry for some eggs. Clayton here says, hey, I want some eggs. Steps into a restaurant. I'm like the waitress, or waiter, I guess. Walk up to him and ask Clayton, so what would you like to have today? He says, like some eggs. I could easily go back and just make some eggs. And I don't really know what he wants, but I make what he wants. But I need to ask those questions. That's my job as a lead or somebody that's working with that requester, that guy who wants that work. What type of eggs do you want? So do you want fried eggs? Do you want boiled eggs? Do you want scrambled eggs? If you want fried eggs, what type of eggs? Do you want them over easy? How do you want them? Ask those questions. A lot of times they don't know. They think they want eggs, but maybe they want hash browns. Who knows? You got to ask those questions for them. Get that information out of them first. And then maybe they do want hash browns with their eggs. Ask them that too. And when do you want your eggs? You want them now? Are you hungry now? Are you expecting somebody else to come in? Get all that information. Clayton loves eggs. He tells me all the time how much he loves eggs. So it's that sort of stuff we want to get out of them. And it's the same thing, no matter if you're a bridge guy, if you're a roadway designer, a geotech designer, somebody comes to you, make sure you know what they really want and make sure they know what they want. Get the real information they want from them, when they want it. And it's basically simple problem solving. Define that problem that they want. So you don't go off and you solve the wrong problem first. So we have this form. Sounds pretty big and cumbersome, but it's really only 3 or 4 pages. Define what they really want, when they want it by. We define internally what we want within our own unit. So like Scott was saying, we want a calc book. We do want preliminary plans. Do we want some specs? When do you want specs? Do we want to have, our designer Clayton here that wants his eggs, is he supposed to go out there and, do a field memo ahead of time? Define all that stuff so he knows. We can hand that document to our designers, and they know what's expected of them and when it is, and the schedule, and the EA, all the information that's there. So it's what we use internally to help define that work, and it's also useful for the requester. We give it to them to review and to have so they know what they want too, and we can refer back to it later on. We can modify it if they want, but sometimes they come back to us and say, hey, by the way, we wanted eggs, we wanted hash browns, we want some toast too. Like, yeah, it's going to be a little bit longer for us to get that toast, but the toast is going to be yours, Clayton. Design criteria and standard assessment, another thing that Scott mentioned. So we get this work order, hand it over to our designer, Clayton, and he runs off and he starts doing his design. The first thing he does, or one of the first things he does, is a design criteria. I look it up there. Design criteria, which basically just sets what design manuals we're going to use, but it's more than that. It's more than just saying it's going to be this list of manuals. Inside these manuals, there's other things. You can say AASHTO code, but what's your design speed? What's your ADT? So we document those things. So we know ahead of time what we're going to design our bridge or our roadway, whatever that stuff's to. So it's our design criteria. It's a living document. You can do it up front. See what you think you're going to need, how much how wide your bridge needs to be, what type of load you're going to have, all that stuff up front early. And if it needs to change, it can change. That's why it's a living document. We want to set that early on so we know what we're going to design our bridge to. And then we do a standards assessment. And what that says is there's all these standards, all our bridge design manuals, all the other codes that we have to live up to. And we have some standards we need to do. So let's say, for example, you're rehabbing a bridge and you want to do a rail retrofit. You want to put a new rail on it. One of our design standards says you're supposed to use a standard bridge rail. All our standard bridge rails are for brand new bridges, not for replacement bridges. So we don't have a standard for that. So we say, use a standard drawing. No standard drawing on our design assessment. That means we have to do a design exception or deviation. Exception in this case, since it's a roadside barrier. So this design assessment helps document what the design codes are. And if we need to modify it with an exception or deviation, we document that also. And all those really are just exceptions and deviations, or just changes to the rules. We have these rules we have to live up to, these design codes we have to live up to. This just modifies it for us, kind of covers us. Lets us know that we're not going to live up to the standard, and there's a really good reason why. We think so as designers, and people that we're working with think so, the area and the people that own that project, but also the owners of those design codes or standards units. They understand the need to modify the rules sometimes, and this is just a temporary modification to those design rules. That's really what design exception and deviation really is, and helps cover you as a designer in the future, so you know that what you designed, there's backing to it. You go kind of outside the rules and you use a detail that's not a standard and you don't get an exception, you might be hanging out there a little bit. So we don't want that to happen. So that's the idea behind this: standard assessment, design criteria, and design exceptions. Scott, talking about quality control. As a user of that, and there's guys here within our bridge section also that use that quality control, we kind of, it's not just one point. Throughout the life of the project, we value quality control from the very beginning to the very end. And lots of people look at it, and not to disagree with my manager because he's standing right there right now, but it is our checker that looks at it. It's our reviewer to look at it, but you also have a personal responsibility to make sure what you send to your checker is good also. So that's another step. Don't forget that step, because you should be able to have your stuff, your specs, your estimate, your plans, whatever that is. Look at it yourself first. Make sure you're happy with it. try to find all those misspellings and whatever else that could be in there. Because once those are cleaned up, then you can look at the overall design that's out there. So we have a personal QC and our reviewer and a checker that looks at it. It's everybody's duty to make sure what gets put out there is a good quality and it lasts throughout the whole project. Everything we do from the very beginning to the very end, before it goes sees public eyes, should be looked at. And that's kind of our philosophy from a bridge design standpoint. Make sure everything is good when it leaves our unit. We also see it as a training opportunity. Because we do have a checker. So Clayton, he's designing his eggs or designing his bridge, and he's experienced designer, he's done it 10 times, he's doing it for the 11th time, and it's pretty complicated sort of design. We have somebody who's never done it before. It's an awesome opportunity for them to be able to check Clayton's work. They get the opportunity to see how those are put together, what those calculations look like, what that project looks like in the end, and at the same time, giving Clayton that assurance that his design is good. So it's a good learning process also. So we use it not just for quality of our unit, but also training of our people to make sure that they're getting the training they need. So once you check one of those, maybe two, then you can go be a designer on one also. It kind of gives you a good, strong foundation to know what to expect when you do your own design also. So we look at the quality control, not just for good for our product goes out to our resources or to the requesters, it's also to help strengthen our own crew. And kind of the last point I was going to talk to you is about project development. I know you guys hear a lot about the DAP phase and these other phases. And just through the years that I've been doing this, the most valuable part of a project is that beginning of it. The strongest you start, you set up you know what the problem is. Get what that problem is. You start with your layout of it. Get all your design exceptions. Get that built up to the DAP phase. That's where all your work really comes in. Once you get that DAP phase, you have a strong project that's well laid out. You know you have the right design criteria set up, and your standards are there, and you have all that done. And the load of work happens before DAP. After that, in that final design or project design goes a lot easier. And there's no surprises. It's those late surprises based upon not having that stuff set up early on is where your troubles really come on. That's where headaches happen. No time to recover at that point. You can find those problems early on. There's plenty of time to recover for that. If you wait till the end, it's bad for you as a designer. It's bad for the owner of the project. It's bad for everybody. So really focus early on that project development phase of your projects. And that's all I really had as the practitioner side. So if any questions for Scott?
You said we needed a practitioner here because the practitioner was going to answer the questions.
I'll answer the questions. Any questions?
Awesome.
Must be the end of the day, no questions.
They want to go home.
Anybody want to go home?
There's the contact information. This updated slide deck will be available at the portal too, that you can replace the one in your notebook. Thank you.
I think it's already on there. I think it's already on the portal.
Oh, that's correct. Yes, that's correct. All right. Well, thank you.
Thank you.